Well, hello everyone. Today I will guide you through the HydroModelMatch tool right here. So first of all, the HydroModelMatch is an app among different apps as you see within the Closed Plumes framework. So you can access the Closed Plumes through the closeapps.aquavio.com/apps. And first of all, you can create an account through the login and use your credentials to use any of those tools, or you can just hit the tool and use it as a guest, just like what we are doing right now. I will just click on the tool and it will go through the HydroModelMatch tool. So this tool, it consists of two tools, a model library tool and a model selector tool. So let's start with the model library. So this model library, it allows the user to explore 58 different watershed and waterbody models that have been used in the literature for the last 4 years at least once. So let's go through the tool. So here are the 58 models. You can choose how many models you wanna illustrate in your website, like 10 or 25 or even 50 or 100, but let's stick to the 10. And you can search here for any model you are thinking about, like the mic. You can see here all the mic different models. And then on the left side here, this panel here are the filters. So let's go through each item in the filters. So first of all, the model, you can just write down the model and it will illustrate it. Second is the water body type. Is it a watershed or water body? If you choose a watershed, you can see that now we have only 40 watershed models. And then the location, you can choose, some models are designed for specific locations, just like those three. And the other means that's for any region in the world. The watershed size, you can choose your watershed size. Is it small, medium, large? Then the predominant land use. Is it ag, urban, forest? Let's choose ag. And you can see the list was reduced to 33 entries. For the water body models, here is the water body characteristics. Is it like a coastal, river, lake? What is the size of the water body? Small, medium, large? For the water body model also, is it a 1D, 2D, 3D model? The simulation type, is it an event-based model or a continuous model for long-term simulations? And then the parameters of interest for the user, is it TP, you want to simulate TP, you want to simulate maybe the flow, Q, and so on. And the time step from seconds to annual, like you can choose here daily, for example. The model complexity, that's based on the computational requirements. Does the model like simple, medium, or complex model? And after that, the simulation objective. What are the objectives of the model simulation you wanna conduct? Is it flood control, for BMB evaluations, for what different objectives? You can choose more than one objective. And non-point source loads evaluation. And then the data requirements. What are the data required by the model? Precipitation, for example, digital elevation model, of course, and different data requirement by the model. And then, of course, the model availability. Is it an open access or a licensed model? And finally, the model limitations. What are the limitations of the model of interest? And like for the filters we applied, we can see that there are 8 models that achieve those filters. And we can just clear the filters. Furthermore, for more details about any of those models, you can visit the model library here through the University of South Florida Civil and Environmental Engineering website. You can see here there are different tabs, including the user guide, some tutorials about the tools, just like the one you are watching right now. You will find it here in the tutorials. And then here are or is the model library. And the model library, it includes different watershed and waterbody models. Go down, scroll down the waterbody models. For example, if you click on the soil and water assessment tool, the SWOT, the famous SWOT tool, you can see very detailed specifications of the SWOT model, who developed the model type, the computational requirements, the software, as well as a link to the model, the strength and limitations of the model, and the model inputs and outputs, and some examples of the model application within the literature. Let's go back to our HydroModelMatch. Of course, if you like click on any of those models, like here, you can see also a brief description of the model. If we go back to the model library, that's all about the model library. Now let's go to the other part of the tool, which is the model selector. So this model selector, it helps the user to select the best model that fits the user's requirements. So also you can see that we have the just like the filters in the model library, but here it's for the model selection tool. So you will start with the water body type. So let's choose watershed, and the location, let's choose other. And let's assume that our case study is a watershed that's mostly agricultural, and it's like a medium watershed. And we are interested in simulating the TP, the TSS, and the flow. And then we wanna simulate those based on daily basis. And the study objective is BMB evaluations, and also maybe BMB locations, like to identify the best locations of BMBs in the watershed. And we are okay with complex model. We have access to high computational resources, so we can use complex models. And we want like an open source model. And then that's very tricky, the exclusion list. So that is the model limitations that the user does not want to tolerate. So that's the model limitations that if it is within the model will be excluded. So here we are focusing on the BMB evaluation and BMB location. So most probably we will need an optimization algorithm to be combined with the model. So for example, here we want a model that can be coupled with optimization algorithm. So we will choose this limitation as an exclusion criteria. So any model that cannot be coupled will be excluded. So here you can see we have a short list of models, those 5 models, that all of those models are feasible and can be applied in the case study. But furthermore, our tool implement a single objective optimization algorithm to choose the best model of those feasible models based on 3 different weights: the objectives, the data, and the model limitations. So here, let's say that the objective is like a 0.4, and the data, we have access to data, so let's say that's the 0.2. And the model limitations, yeah, we do not tolerate with that, so it's a 0.4 also. And if we run the model selection, you can see that each model has a score. The highest the score, the best the model. And we can see that both the SWOT and the SWOT Plus, which are very similar, got the same score, the 3.1. So that means both of those models are the best models to be implemented, but our tool will choose just one for us, which is the SWOT, which makes sense because like SWOT Plus require more computational requirements than the SWOT. So the SWOT here is the best model to be used in our case study. And furthermore, you can see more details through the user guide. You can log into the user guide and get more details on how to use the model library and the model selector tools. And if you need any help, or if you want to contact us, you can just go to here again, the USF website, and you can find that the contact us here. Those are the contacts that you can contact us asking about any further information or anything you want to ask about. You can reach out to any of our 4 PIs. That's all about the HydroModelMatch tool. Thank you.